Okay, in this video I will be doing two of the percent composition problems. So the first one are working with these tables. Okay, so the first part here, we have Al2SO3 aluminum sulfide, and so we have an element, so we're just going to pick either one of these. Let's just go with aluminum for our first element, and our second element is sulfur. For aluminum, I see that I have two elements there. So what that's telling me is there are going to be 2 moles of aluminum in that compound, and since there's a 3 there, that means I'm going to have 3 moles of that element to make this compound work. All right, so the molar mass from the periodic table, when I go to my periodic table, aluminum is here, 26.982, and sulfur, which is 32.066. Both of those came directly from my periodic table. All right. So now to find the total molar mass, I multiply the mole number, the subscript number, by the molar mass for each of them. So when I do that, 2 times 26.982, that gives me 53.964. And then 3 times 32.066. For sulfur, I get 96.198. Now, for the entire grams per mole, the entire molar mass, I just add those two numbers together, these two numbers right here together. So when I do that, 53.964, I should get 150.162. So when we do a percent of anything is always the part over the whole multiplied by 100, and that should give you a percent. Okay, that should give you a percent. All right, so here is your whole number. That's what the entire compound is made of, and here are each one of your parts. All right, so if I want to know the percent composition of aluminum, I take 53.964, and I divide it by the whole number, which is 150.162. Multiply that by 100, and that should give me 53, my percent composition of aluminum. 50.162, and I get 35.94. Okay, now the rest of it should be your percent for sulfur, because when I add up these two percents, they should come out to be 100. Now, I could take that minus 100, or I could actually calculate it. When you do it on your quiz or your test, you need to actually calculate it by doing this exact same process as you did over here. So it should be 96.198 divided by 150.162, and you get 64.06. Okay, and that actually does come out to be exactly 100. If your percent comes out to be, your total percent comes out to be 99 or just over 100, that's okay, because sometimes we do some rounding in this area to make this number not quite 100, and that's okay. All right, so that's the box examples. When I go back here to more of my word examples, you'll see a lot more of these on your test. So if I do number 2, determine the percent of magnesium in magnesium fluoride. So the first thing I need to do here is take this name and put it into a chemical formula. All right, so I have magnesium, which has a +2 charge, and fluorine, which has a -1. When I cross those up, my chemical formula is MgF2. All right, so if we don't get this correct formula, it's going to be very difficult, and actually you'll probably get it wrong because you're not using the right numbers when you do the math. Okay, so if I break this down into magnesium and fluorine, okay, I have in my correct formula, I have 1 magnesium and 2 fluorines. When I multiply each one of those by their let's do this. We're going to multiply each one of those by their molar mass. So magnesium is 24.305 and fluorine 18.998. So I'm going to multiply that, and when I do that, 1 times anything is itself, 18.998 times 2, 37.996. Okay, so here are each one of your parts, and when I add these together, it should give me your whole molar mass of the entire compound. So then add 24.305, and so my molar mass of my entire compound is 62.301. So in the question, determine the percent of magnesium. So I need to find magnesium. So what I'm going to do is I'm going to take magnesium and divide its molar mass by the entire molar mass, 62.301. So 24 goes in your calculator first, then divided by 62.301. That should give me a decimal of 0.3901, and then I multiply that by 100, so I get 39.01% magnesium. Okay, so that's how you do percent composition. I hope that helps.